Today, I want to discuss about the communication between 3D printers and the PLCs. Yeah. So, what I've done so far is here is a Prusa Mark 3.5, and there's a Raspberry Pi here. This one. And printer and the Raspberry Pi is hooked up via USB communication. And then Raspberry Pi hooked up with Wi-Fi and Wi-Fi to my computer, actually, not PLC. But well, let's estimate this as a PLC and HMI both. So 3D printer, Raspberry Pi, PLC here. So and I'm using Octopi on the Raspberry Pi. So Octopi has got its own API. I tried using Prusa Link and Connect API, but I could read the values, but somehow I could not send any command through G-code. So, but luckily Octopi could send the G-code to the 3D printer. So I'll show you how it works. Let's put it there. And this is my HMI. Sorry, it's written in Korean. So X, if I put 1 is X-axis, 2 Y-axis, and 3 is Z-axis. So I'm gonna put one axis, X, and I wanna move 10 centimeter. So let's send the comment. It went that way. That was too short, so 22 centimeters. So if I send a command, yeah, it moves. And if I put 4 in this parameter, it goes to home mode. Yeah, it's moving. Oh, it's reading it's got Octopi signal sign over there. So, and now I'm gonna do temperature control now. So I'm gonna add. So 400 means 40 degrees Celsius. So I'm gonna add six. I'm gonna put 60 degrees in each nozzle and hit bed. So send command, and it's gonna rise. This is gonna rise soon. This is the current, left one is current temperature and right one is the set temperature. And let's check auto print. I see, so I send some signal via, send some G-code command. And let's see, where is the, so there you go. Hit bed and nozzle and hit bed sent. So temperature is rising as expected. Oh, this can be done quite easily via G-code using Octoprint, but what I'm trying to do is I can send from this industrial communication called Modbus to using this translator and convert it to G-code and G-code to the printer. So as an embedded system, like embedded control microprocessors, they have their own thing, and industrial PLC, they have their own things, and that microprocessor has got a lot of freedom which PLC don't. It's got like OPC. You can only use certain communication port like Ethercat, Modbus, OPC, and barely Ethernet. So yeah, that's so what I was trying to do using this translator, so that both can talk each other. And I could only read values from 3D printer now, and now I could send the signal and set the temperature as what I want. So this was like a small project I've been doing, but thanks to AI, it helped me a lot. And what I want to do next is, this is a Thunderbolt 3. It's got ROS 2 in it. Jazzy, what is it? Humble. ROS 2 Humble OS inside. So using this Raspberry Pi or whatever the hardware that required, I want to talk between 3D printers, robots, and PLC all together at once, so that I can have very interesting factory style, I guess, in the future. Well, some large company might already doing it, but I want to do it on my own way using open source devices. Oh, this one is not open source, but by the way. Anyway, this was what I was doing, and here's my small 3D print farming there. It's got XL and MK 3.9. Tell me if you're interested. Oh, maybe I should go look for it. Maybe show tour later. So this is what I've been doing, and let me know if you wanna ask question, or you can give me some advice. So thank you very much for watching, and hopefully I can also do interesting things, and I can do many things like this is in-wheel in-wheel drivers and motors to have fun with it. And alright, so thank you for watching. Bye.